Thanks. Logan, you want me to turn it so that you're in there the whole time?
No, that's a joke.
I don't mind.
It's only a joke.
All right, so for the first few questions, when you see the word solve, usually when you're solving for X. And so solving means get X equals. That's what it is. Solving means get X equals. To get X equals, you have to solve by factoring. So factoring is that thing that we did where we have the X and the X, and you have to look for factors of 18. So 1 and 18, 2 and 9, 3 and 6. And so they need to multiply together to make 18, but we need them to add together, subtract, to make 3. So which pair could work? 3 and 6 could work. So then you got to figure out the signs. The middle number is positive, so the bigger number has to be positive. If you have 6, would you add or subtract 3 to get 3? Okay, do I have X equals? No, all I have is factors. To get X equals, I have to set each one of these factors equal to 0 and then solve for X. Because 3 and 6 multiply to give you 18. So you have to multiply to give you the last number, and then add or subtract to give you the middle number. So -3 times 6 would give you -18, and 6 minus 3 gives you 3. If I solved for X, I would have to add 3 here and subtract 6 here. So I get X is equal to 3 and X is equal to -6. You'll also notice that once you get your factors, do you see how when it's a factor, it's -3, but when you get X equals, the sign just changes. It's just opposite. So if you don't need to do that step, that's fine. Here it's 6, but X equals -6. It's always going to be the opposite number every time. For question 2, it also says solve. What does solve mean? Get X equals, that's our goal. And so it doesn't tell us factoring, but it's written in that same pattern. So anytime you're written like a quadratic, so quadratic means you have something squared, you're going to do the same thing where you get X and X. And you're looking for factors of 49. Not a whole lot. We've got 1 and 49 and 7 and 7. So which one of those pairs can be put together to make 14?
7 and 7.
7 and 7. When I look at the middle term, it's negative. So that means the bigger number has to be negative. Well, they're the same, so they both have to be negative. If I set that equal to 0, what does X equal? Just +7. Remember, it's just opposite. And I only have to write it once because, I mean, it's like,
It's the same.
it's the same. Okay, roots. There's other words for roots. When you're looking for roots, there are also solutions, which you're solving. So again, if you're solving, roots are solutions. That means they are also X equals. So this one is a little different though. Do you see how this one has a negative X squared? You can't work it the same. First thing that you have to do is get rid of that negative. So to get rid of the negative, you have to divide everything by -1. And then that means that you're pulling the -1 out into the front. So that'll make that positive, and then 18 will be negative. So anytime that you have a negative out in front, you have to divide that out first. Now we can factor though. So I need to figure out factors of 18, which I already did up above, but that's okay. I'll get more practice. I'll write it down again. I have 1 and 18, 2 and 9, 3 and 6. Which pair can put together to give me +3?
Question 3 is like question 1.
It is a lot like question 1. 3 and 6 will also work. The middle term for this one is positive. So my bigger number has to be positive. And it's just like number 1. If I have 6, I would have to take away 3 to get 3. When you set these equal to 0, the -1 out in front doesn't matter because there's no x there. So there's no x equals. So you end up with x is equal to +3, -6. Oh, well, we already did that question, didn't we? The next question is, what are the y-intercepts? Y-intercepts are when x is equal to 0. So we're going to rewrite the equation and leave a spot for the x. If x is equal to 0, that's what I'm going to plug in right here. And then I'm just going to evaluate. What's 0 times 0 or 0 squared? 0. What is 5 times 0? That's it. So y-intercepts are when x is equal to 0. So you can just plug in 0 for x. The next few questions, it says in the xy plane, the graph of the equation intersects the x-axis at how many points? So like this whole test or quiz and the test that's going to come up is all about quadratics and population growth. But quadratics, we have to know what that basic shape is. So anything that you have that's x squared, it makes a graph, and the graph looks like the letter U. It looks like that. That's the basic shape. Please write it down. That's the basic shape for x squared. So anytime you see x squared, that's what the graph is going to look like. So when you're taking TSI and it asks you a question about like how many times is this going to cross the x-axis, you need to know the basic shape. It looks like a U. And then looking at the equations, you don't need a graphing calculator. You don't have one. But we need to know how these things move my graph. So normally your graph is going to end, or it's going to be placed right on the x-axis, just like that. This first one, it says that it's going up 1. So instead of being right on the x-axis, it shifts up. I don't have to scale my graph. It doesn't really matter. It just goes up. It's just moved up. So how many times does that cross the x-axis? None. None. It doesn't cross at all. The next graph. Am I moving up or down at the end? Does this graph tell me that I'm moving up or down? No, so it stays where it is. All the 2 does is tell me that I get there twice as fast, but that doesn't even matter. So I'm going to stay right on the x-axis like that. So how many times does it cross or touch? Once. The next graph, what does -1 tell me to do? Go down. I mean, where you put it doesn't matter. It just goes down. So for this one, how many times do I cross or touch the x-axis? 2. So you don't have to have a graphing calculator to know exactly where this is. The question is, how many times does it intersect the x-axis? That's all you have to know. Did it move up? Did it move down? That's it. That's it. Question number 6. It says, what's the positive x-intercept? That's pretty important. Positive x-intercept for the equation. So x-intercepts are x equals. So to get x equal, we factor. So when I look at this one, same thing we've been doing, that I got to take 35 and I need to make factors. So 1 and 35, what else? What else multiplies to give you 35? So which one of those factor pairs could put together to make 2? 5 and 7 would work. When I look at my middle term is positive. So my bigger number, which is this 7, needs to be positive. Hello? Hey. He is, and I asked him if he's supposed to be with you. He's saying he is not doing it. You're not telling me something I don't know. Are you gonna go, Jaden? Yeah. He said, yeah. All right, thanks. Bye. They just keep adding days. Just go sit it out, get it done. If I have 7, would I add or subtract 5 to get 2? I'd have to subtract. And so if I set each one of these equal to 0, then I get x is equal to, what does this one make x equal to? Positive 5. And then what does this make x equal to? Negative 7. So which one of these is the positive x-intercept? We just have one more on this page. It says, what's the vertex? We did this last class. To find the vertex, you have to first factor to find the x equals. So I'm going to do that. We've got to factor. You have to factor and factor and factor all over this quiz today. So I got x and x, but I need factors of 8. 1 and 8, 2 and 4. I need a factor pair that can put together to make 6. Very good. 2 and 4. So if I use 2 and 4, my middle term is negative, so my bigger number has to be negative. If I have -4, would I add or subtract 2 to make 6? Because I got to get more negative. So when I get x equals, What are my two x's? Positive 2, positive 4. Okay, done. We have to factor to find the x equals. First step, done. Second step, it says graph the roots to find the middle. We don't have a graph. It doesn't really matter. All I need to know is if on a number line, if I have 2 and I have 4, what's in the middle of 2 and 4? 3. Okay, the middle is 3. That tells me, because our vertex, remember a vertex is an x comma y. So I just figured out my middle number. It's the x and it's 3. So I'm going to take that 3, the last step, plug in the middle number, it's 3, to find y. So we have to plug it into our equation. So I'm going to take my equation, I'm going to pull it down here so that I can plug it in. So I have x squared minus 6 times x plus 8. I'm taking that middle number, which is 3, and I'm plugging it in. To evaluate this, we got to go step by step because we've got those simple function calculators. So the first part, what is 3 times 3? 9. What is 6 times 3? 18. So I get 9 minus 18 plus 8. What do I get? Okay, so that is my y value. Oh, why did I do that? It's not what I meant to write. I meant to write -1. So that is my vertex. We have a little bit more on the back before we get there. I think this is a 3-minute video. Oh, we want volume.
Today would be the day that I'm turning my entire world upside down. The whole inside life will change for you. A better life. You're only company, more money, more happiness, a better, stronger body, a relationship. All your feel more happy. Today, you can make this connection.
Okay. On to the back. It says, what is the equation of the parabola graph? I bet you didn't even know that you could make the equation of the graph. But you can. To find this equation, we first have to figure out the roots. So what are the two numbers? Where do we cross the x-axis? We've got -3 and +1. So we're going to put those. We've got x is equal to -3 and +1. We're going to work backwards. So if we have x and we're putting these in here, if I have -3, when it goes into the parentheses, what's it going to become? +3. They're going to be opposite signs. So +3. And then the one's going to become a -1. They will always be opposite. So it might be a good idea to write down that word so we don't forget. Okay, they're opposite sign. Well, to write my equation, an equation of a line is going to be f of x. And we're going to have something there. To figure out that something, we can use FOIL or a box. It doesn't matter. I don't care what you do. Most of you like a box, so I'll make a box. So we have x plus 3 and x minus 1. If we multiply in, we get x times x, or x squared. I'm going to stop talking and fill in my box so that you can fill in your box. Combine like terms, I have x squared first, and then I have 3 minus 1, or 2x, and then minus 3. That is my equation. And y'all should feel smart. That's really big kid math. The next question is a population growth question. This is the stuff we did last time. It says in 2019, the population of a town was 27,580. These numbers go together, so I'm going to connect them. And then it says by 2025, the population increased to this. I'm going to connect these because I don't want to mix them up. Assuming the town's population is increasing linearly, any of the questions I ask you about population, it's going to solve the same. So they're always going to be linear growth, even though that's not realistic, but whatever. We're going to figure out the population in 2029. So to do that, I need to make a table, just like I did last time. And I'm going to have the year, and I'm going to have the population. So I'm going to write down what's given, starting with the earlier year. So the earlier year that I have is 2019. And in 2019, I had 27,580. 2025, I have 51730. What I have to do now is I have to figure out the change in years and the change in people. So from 2019 to 2025, how many years is that?
6.
So I'm adding 6 years. And in 6 years, how much is the population increasing?
Uh, 24,150.
All right. So to figure out the population in 2029, how many years is that from 2025? 4 years. Okay. Well, we don't know how much the population increases in 4 years. We know how much it increases in 6 years. So it's going to be helpful if we figure out how much it increases every year. So I can take 24,150, and I can divide by 6 to give me my yearly rate to figure out how much it increases per year. Okay, so I'm adding 4,025 each year. So if from 2025, I need to add 4 years, then I could also figure out that like 4,025, I could multiply that by 4 years to figure out how much I'm adding. So how much do I have to add to the previous population? Okay, so I'm gonna add to my population that I had. So I had so I'm adding those things together to figure out how much population I had in 2029. I don't think it's 40. Uh-huh. It has to be a number bigger than 50,000 because you're starting with 50,000. So I got 67,830. Is that what y'all got? And then it says, what year will the town's population be 83,000? So I can keep adding by each year. I could add by every 4 years. I could add by every 2 years, whatever I wanted to do to figure out when is my population going to be 83,000. So I'm going to wait for you guys to see if you can figure it out. What'd you get? Let's see if other people agree.
Just gotta add 4 more years and Yep.
I'm waiting on y'all to do this. I'm not going to do this. Y'all have to do this on your paper. Eric, what'd you get? Okay, what'd you get in 3 years? Okay, so you have to add that to the 67 to see if you have 83,000 yet. Not quite. So you might have to add another year. For this question, it is an open-ended question on your quiz. That means you have to show me work or you don't get credit. So if you just do it all in the calculator, I'm not giving you credit for just an answer. You have to make the table. You have to show me what you did. Bella, what'd you get? What is that? Do what? Why? So maybe you just need to add one more year? Eduardo, what'd you get? And what year does that happen? Miles, what'd you get? Do you know what we're doing at all? Sleeping through the review is not going to be very helpful. Juliet, what'd you get? Alex, you get something?
I still got the year 2033.
And that is correct. If you do it correct, you will figure out that in the year 2033, you have 83,930. And so it's when is the first time you will have that much? Well, I have 83,000 there. So it is in the year 2033. Again, please make sure that you show me the table. Please make sure that you show me things like this, that you figure out the yearly rate. The last question, it says the circle graph gives the distribution of colors of gummy bears in a bag. If there are approximately 60 gummy bears in the bag, which is the closest to the difference between the number of green and orange? This question happens all the time on TSI. We need to know how many we're talking about and then what the 2% are. So we've got green and we have orange. We want to find the difference. Well, if I have 60 gummy bears, the number of orange, I have to multiply by the percent as a decimal. So 0.15, that will give me the number of orange. 60 times the percent of green as a decimal, 0.20, that'll give me the amount of green. So how many orange gummy bears do I have? What? Mhm. Okay. How many green do I have? So the question is asking you the difference. So the difference means that what's the difference in 9 and 12? Very good. That's it. You have 5 minutes to study over this practice. And then we will take our quiz.